Hello, everyone.
Hey.
Hello.
How's everyone doing?
Good.
Hello. Can you guys hear me?
Yes.
I'm Mr. T.
Ah, Mr. T, nice. Nice to meet you.
Yeah, what a great name.
Yeah.
Okay, we'll wait a couple of minutes for people to join.
Where are you all from? I'm from Germany.
I well, I'm based in Berlin, but I'm not German. I'm English.
Good for you.
Actually, I saw a tweet today. Henry from Penumbra posted, which I found funny. It was saying people complain about their lives, and then they realize that there are people living in England. But I don't live in England, so I moved on from there, but
Yeah.
it made me laugh.
And since when do you live in Berlin?
I live in Mitte, so very central.
For how long now?
Almost 3 years.
Oh, I was recently 2, 3 weeks ago in Berlin.
Oh,
There's
really?
an excellent Vietnamese restaurant, Mr. Vuong, Monsieur Vuong.
I think is it in Charlottenburg?
Yeah, because one of my hobbies is really cooking. Yeah,
Uh,
yeah. I
yeah.
can send you the link where the restaurant is.
Yeah, send it to me. I'd love to check it out. I love cooking, but I love more when people cook for me, obviously.
And I really love to cook for a lot of people. Yeah.
Oh, okay. I'd
Yeah.
love to try someday.
There were times I was where I really was cooking almost every weekend and invited 10, 15 people.
Oh, nice. Would be good to be one of your friends.
I was more than 10 years in Switzerland. I don't know how the Swiss culture is different. And then I came back to Germany and I had the feeling I had to catch up and just like, okay, inviting tons of friends.
Nice, nice.
We socialize. Yeah.
Yeah, that's cool.
All right, I think it's
Yeah,
time to start. Yeah.
yeah.
Yes, this part is definitely including the recording. No, not yet. Not yet. I didn't start the recording yet. So, but I will share the screen and start the recording. All right. So, welcome to the IBC community call. Yeah. So we have the updates from the teams, and then we have Mr. T from ARC Protocol to who will give us a presentation about their work on ICS 27. So yeah, we should have enough time. We have an hour, and looks like we don't have many updates from the other teams, so maybe we will finish early with that part. But Susanna, do you want to start with the product update?
Sure thing. So first of all, as a little ask, if you haven't already seen me messaging, asking for you to fill out this survey, please do it now. It will literally take 2 minutes and it'll be a really important data point for motivating funding and road mapping decisions for the ICF. So please just click on the link. I don't know if someone can just drop it in the chat as well. It will literally take 2 minutes. Permission to do it whilst listening to the community call. So yeah, that's the first point. Second is I've written up some ICS v2 requirements. So we saw like a lot of people having problems with using Interchain accounts, particularly those that want to use like one user per account. Basically not really the feature in its current form doesn't really scale. It's really difficult to use with the relayers and querying all the channels on startup. Amongst a few other pain points, basically aggregated them into a requirements document. And we also have a bit of a discussion thread going on, which you can click through the second link. And there's also a kind of small, I don't know, working group, but it's basically just like a Slack channel where people can talk about their requests and wishes for things in a second version of Interchain accounts. I know we don't have that many people here, but I guess open question if anyone has any wishes that they want to express now, feel free. But if not, I'll just move on. I will move on. So another thing we've been doing is looking into something we're calling IBC Lite, but it's not don't know, the name is to be determined. Basically we observe a problem that many people are interested in joining the IBC network, but the kind of effort required to have a fully working implementation if you're not a Cosmos chain is a lot. So we're exploring if there's a way to simplify the deployment for other chains. So I've just been talking to some people about that and their thoughts on the idea. And yeah, and then I just dropped a couple of blogs that came out from last month. So there's a comparison of IBC and CCIP and the contributor showcase. So shout out to Ben from Union for winning the contributor showcase last quarter. Yeah. I think that's everything.
Thank you, Susanna. Any questions or comments? If not now, then we can move on.
I'm going to drop the link for the survey in the chat in 1 second.
Thanks.
So sorry, Carlos, I was a little bit late. I do have one question about the IBC Lite. Can you expand a little bit on what the thinking is exactly? Because from my point of view, like I feel like a lot of people feel like the strongest part of the best part of IBC is like the transport layer. And it seems like this would be like an attempt to kind of, strip away a large part of the transport layer. So you're just wondering about that direction, like maybe it's the idea to like see if this would be possible, like see if people are engaged with that idea, and then kind of like let the market decide what the best way forward is. Or can you expand?
Yeah, great question. Yeah, Susanna, yeah, and Aditya is also in the call, so
Yeah. I can answer from a validation perspective. Obviously, what I'm seeking to do is first of all gauge interest and then also check what the requirements are. So for example, if you're saying that if it turns out that the transport layer is a really, really core component that is like a must-have, and there's certain functionality that's delivered through the connection and channel abstractions, then, you know, that would feed into the design. Like, this must be a possibility that should be able to be, like, it should be a feature of the implementation. But Aditya, I don't know if you want to say anything.
Yeah, absolutely. So yeah, I think like we're trying basically to make sure that the core security guarantees of IBC are maintained, and the application level semantics are still maintained, without requiring so much setup and implementation work in between. So it's kind of like, okay, we want to ensure that we still have light client-based security, and we want to still make sure that the packet semantics of send packet, receive, acknowledge, timeout are still there. And there's a lot of setup in between those two steps, and trying to minimize that as much as possible is kind of the goal of IBC Lite. So we think that kind of is ultimately the essence of IBC, and everything else is trying to just enable that. Yeah, there are of course going to be some things that we can do with regular IBC that we're not capable of doing with IBC Lite, right? It is a slightly stripped down protocol, but the core features are still there. And, you know, eventually I'm going to write up basically like, here are the kind of things you can do, things you can't do with IBC Lite. And then I imagine people will kind of understand, okay, there's one implementation that's much easier to implement and it doesn't have these certain abilities. And then there's the current IBC that we've validated is very hard for people to implement, but has, you know, maybe a slightly bigger superset. And yeah, I think it is probably the case that for a lot of these things, for a lot of these changes, they're going to be okay with IBC Lite, to just give the Lite client based security and have the IBC application network completely at their disposal.
Okay, thank you for that. Maybe one follow-up question about the compatibility. I haven't had the chance to read in detail the issue or the PR that was linked. But like, for example, at Polymer, what we're doing is like with virtual IBC, we're kind of taking a different approach to like solving this issue, in the sense that the Polymer chain would still have the most like, you know, feature-rich IBC Go implementation. Then it is just about like deploying virtual IBC contracts on the virtual chain, so in their VM. So it's kind of like a, you know, a different way. If there were two chains or rollups that pick, for example, like virtual IBC, and then the other one picks IBC Lite, would they still be like compatible? Could you like, you know, still connect over the two, or you know, create a channel between those two?
Yeah, so absolutely. We want to make sure that, you know, we don't want to split the network, you know, create two fragmented networks of value. We want to make sure that it's ultimately one IBC network that's growing. But the way we plan to do that, right now we're just validating that this Lite thing even works and that it's secure in the way that we expect it to be. But of course, we will, like, in order for this feature to be viable, with some changes to regular IBC, regular IBC basically should be able to implement IBC Lite as well. So a chain that's running regular IBC in the future will be able to talk to both other regular IBC chains that are running clients, connections, channels, and then they'll also be able to incorporate and receive packets from IBC Lite chains, and then they'll just do the IBC Lite logic on their end as well. So, but that is in a sense a subset of the full protocol, so it shouldn't be a big lift to do backwards compatibility, but that's something we will also test on our end. Like, I don't think this feature or this solution works if it entails two completely isolated networks.
Yeah, makes sense. Thank you for explaining.
All right, thanks, Thomas, for the questions. So we continue with the updates from IBC Go and specs. So this morning we released 7.5. yeah, we backported to this release line some ICA improvements. Those are the support for unordered channels, which was released in January in 8.1, and also ICA queries. So that's also now in 7.5. And yes, yeah, in a couple of days, yeah, probably this week, still this week, so we will release 8.3, which also will have ICA queries and conditional clients. Yeah, so that's a bit on the releases side. We're working, yeah, now on V9. V9 is gonna be ICS 20 v2, like as the flagship feature, let's say. But yeah, we've been also working on adding support for dependency injection to IBC Core modules. Yeah, and on IBC and on ICS 20 v2, we've been working on the multi-token support for transfers. Yeah, we have a feature branch with all the changes there. Yeah, and we need to do now a bit of polishing and yeah, some internal walkthroughs to get everyone up to speed with it. But then we will continue with the ICS 20 v2 path forwarding changes. Yeah, there's a spec PR that Aditya wrote. And we also have now a Queen spec that Stefano wrote to verify certain invariants and test cases for the spec. So that's going to be a lot of our focus in the next few iterations, ICS 20 basically. And then on the ecosystem expansion, so yeah, we decided to pause the POC that we were working on for the sidecar approach to integrate with the OP stack. Yeah, so we did a POC for a few iterations in the last quarter. Yeah, and we did an evaluation of that POC, and yeah, basically, yeah, it's a complex approach. It's not easy to generalize to other ecosystems. So yeah, we have decided to put this a bit on hold for now and explore the IBC Lite or simplified IBC approach. Yeah, and Aditya and Serdar are working now on a POC. Yeah, and that will continue in the next iterations as well. All right, so that's a bit the updates from engineering specs. Any questions about this or?
Can you share a little bit of the, what are the more difficulties you have seen, Aditya, on, integrating the OP stack?
Question for Aditya or?
Yeah, I mean, the people who worked very intimately on it are not here on this call, so I think they can give very extended detail to you, perhaps on the Polymer sync that we have, but I can give you maybe just a high level. It's not that necessarily that it was difficult to integrate into OP stack specifically. I mean, we could do it with a bunch of OP stack specific code, but the point was like, if we did it for we wanted to use OP stack as a test case to see if this could generalize across ecosystems. And what we realized was we could build a solution for OP stack, but then like not as much as we'd hoped could be reused for a second ecosystem and for a third ecosystem. So it would be like a lot of independent use cases for each one. And we also realized that there's also just convincing people to run sidecars on their rollups might not be the easiest approach. So yeah, I think it was more the generalizability was a big factor for us.
Thank you.
There's also an issue in IBC Go, and I think Colin wrote a comment with the findings after the first phase of the POC, and we should still write another comment, probably explaining why, explaining better why we're putting this on hold for now. But yeah, if you check the issue in IBC Go, you should get some more information there. Okay, so then, yeah, the rest of the people from the other teams, yeah, Informal, Strangelove, Penumbra are not here today. So we will not have updates from them. So we can, in that case, unless somebody else has any other topic to discuss or questions. Otherwise, we can jump to the presentation. Okay, let's do it then. Then Mr. T, let me allow you to, you can share the screen. I will stop sharing the screen now. And you can take over.
Yes, let me do this. Okay, everybody can see my screen?
Yes.
Good. So I've sent you the link for the demo I'm going to show you. And it's all described in the README file. Just let me walk through that. Quick about us. Our mission is like basically build an interchain NFT hub. Technically, on a general level, we are trying to transition NFT utilities from a local single chain to a global and interchain level. And so far, we are the main contributor on CW ICS 7.1 and CW NFTs. Like for ICS 7.1, obviously interchain transfers. We have added some extra contracts to that one besides the basic default ICS implementation. Design-wise, it's just the same like ICS 20, but we have added outgoing and incoming proxies to that one. This way, for example, we are able to whitelist channels, for example. So between two chains, you know, IBC, you can set up multiple channels, but with the proxies in line, it is possible to say you can only send NFTs via this channel and nothing else. And if you're using another channel, then it just throws an exception and it tells you it's not whitelisted, for example. This way we can avoid fragmentation for NFTs collections getting created on the other chain via different channels. Yes, CW NFTs, we are adding some additional contracts with the CW 7.1 exploration, for example. There's going to be a new major release for the standard, the CW 7.1 base collection, which is the main thing is like that we have added some creator logic to that one. As you may be aware of, like there's you can define minter for the collection contract where only the minter is allowed to mint an NFT. But now with the creator that we have added, you are able to update existing NFT data. So the creator is able to update this. And most importantly, is like we have added collection metadata. So far, in previous releases, collection metadata, it only contained name and symbol, but for NFTs, it's, for example, very important to have royalty info. So this is important. So for the next version of ICS 7.21, we can pass collection metadata like royalties from one chain to another chain as well. We're also working on some other interchain products and utilities like launchpad marketplaces. Currently, the ICS 7.1 is not transferring the on-chain metadata, but it will with the new changes that's coming with CW in this release. And so the demo I'm going to show is like I've deployed all contracts on Stargaze and Testnet. And there's also a description here where with a lot of scripts where you can really set up, upload the contracts and set up the ICS, the contract and the proxies. What I'm going to show you is 3 things. One is like minting NFT. The other one is transferring NFT from Osmosis to Stargaze and transferring back to Osmosis. And I'm also going to show you how this works with callbacks. Callbacks, we store them in the memo that I can show you in the code. So if you mint an NFT, like this example, this passport NFT on Osmosis, it's going to look like this. But then in the next step, if you transfer this NFT to Stargaze, I've added a callback that will do 2 things. So on receive, it changes the metadata of this NFT, and on the target chain and on the source chain on Osmosis, it's also changing this one. So this is the original PFP. Once transferred over on Osmosis, it's escrowed. So we are really visually showing that we are telling it it's away. So it's escrowed on Osmosis. And on the other side, like on Stargaze, it gets this Stargaze stamp so that you can see, okay, the NFT has been transferred over. In addition, it does also an extra example so that to show that you can call multiple contracts on the receive callback. It does 2 things. It changed the existing NFT and it mints another POAP NFT. So let me show you that. Here, there's the mint script. Let me mint one on Osmosis. And this is NFT 29 here. And this has been minted and owned by me, by my wallet. Now I can transfer this Osmosis FT number 29. Osmosis. And so the initial NFT, so there I've stored 4 on-chain metadata. This is the PFP that is showing. There are 3 more attributes added, like the default URI, the escrowed URI, and the transferred URI. Now it's relaying this packet. And of course, here, as long as it's not relayed. No, okay, it is there. Good. Now it has been relayed. So the collection has been created and the NFT has been minted on Stargaze side. What has changed here due to the callback that it is updating the NFT using another URI, and it's actually this one that is used for the token URI. So you can see it here in this PFP. Original, it's here on Osmosis, and now it looks here. If on Osmosis I do a refresh, what you will see is like the NFT is escrowed by ICS. Let me refresh that one. Yeah, so this is the ICS contract, and the token UI has changed. As you can see here, it has this away stamp. Okay. So NFT passport transferred from Osmosis. Now it's escrowed by ICS. And on Stargaze side, it arrived here. And then I can transfer this back. Stargaze, need this collection address. And same thing like with ICS-20, once it gets relayed on the back transfer, the NFT is burned on Stargaze side. And then it will be unescrowed on Osmosis side. The contract that is being executed by the callback on the egg callback, what it also does is just like it will reset the token URI back from being escrowed to its default URI. Okay, and now let me refresh this one. And as you see, the token URI has been changed back to the default URI. Also on the console, the script, what it does, it really tells you that on Stargaze side, it got burned. Yeah. And Osmosis side, you see that the token URI has been set back to the home URI. Any questions so far? We can have a look briefly in the code. So wait, let me check in the README. This is here. These are the scripts. So in the example, there's this main contract. It's called Arcade Passport. It acts as a minter. So when an executing a mint, it's executed on this contract and mints an NFT on the CW721. And it also acts as an incoming NFT. So if you send an NFT from the collection, you send it to the Arcade Passport, it forwards the NFT to ICS721. Then also it does the handling of the receive and egg callback handler. As I explained, so on the receive callback, it does two things. It updates the NFT metadata and it also mints a POAP NFT. I think it should be also, yes, here. You see, so another NFT has been minted as a proof of a tendency. So you get an extra NFT because you didn't interchain transfer to another chain. The egg callback, the only thing it does is like it updates the NFT, resets the token URI back to its original value. So technically, the flow, what it does, like you do call an ZFT from the collection contract and pass it to the Arcade Passport. The Arcade Passport itself just transfers the NFT to the target chain by using ICS. So it attaches and receives an egg callback, forwards it by just doing the same thing, calling send an NFT to the outgoing proxy. This then passes to ICS, and then ICS does all the packet, it sends it, and then does all the collection, instantiation, and mints the NFT. Okay, what I can also do is, for example, before we get into the code, is like, as I said, with the outgoing incoming proxy, we have whitelisted channels. So for example, I have this channel is whitelisted and this channel is not whitelisted. So if I would adjust my transfer script, yeah. replace this. And if you send it through a channel that is not whitelisted, then it's going to error. Let's mint another one. It is going to be NFT number 30. This is the one. And then transfer it. Osmosis number 30. The testnet is sometimes not very reliable, so I need to manually clear the packets. No, not there yet. Oh, it was. It failed. And then if I refresh this, and yes, exactly. So nothing has been transferred to Stargaze. So what I'm getting here is like not found, NFT not found here. And the NFT is returned back to Osmosis. So let's have a look at the code. Let's look from here. The starting point would be the receive NFT. I get a message from the collection contract. And what I basically do is just like, first I need to figure out where the ICS has an outgoing proxy defined or not. So if there's an outgoing proxy, I'm going to use that. Otherwise, I'm going to redirect it directly to ICS 721. This is the most interesting part. So where I'm attaching the memo to the IBC message. And here, what you see is, hold on, let me move this away. Here, I'm creating the callbacks. You can attach any arbitrary callback data to it. So you can define your own data that you want to pass. Like for me, it's sender, token ID, and the free token URIs. I'm creating the callbacks. So both ACK callback and receive callback are optional. The address is also optional. In case of none, the callback is sent to the recipient, for example. And in case of none here, it's sent to the sender who has sent that. In that case, it would be the arcade passport. So I'm attaching my callback in my memo. Here, and just do a set NFT. That's it. Once it's sent, it forwards it to the outgoing proxy, to the ICS, and then the relayer relays it to the counterpart of ICS. And then when the callback is called, like for the receive callback here, then I'm getting my message. And from the message, I can extract my callback data. And then I can do any execution, whatever I want. In my case, I just update the NFT info here, extracting the data from the callback. I still need to make a distinction to figure out the receive, whether is it on the home chain or on the sub chain. So so on the forward and on the back transfer, there's a difference. So if I do a forward transfer from Osmosis to Stargaze, yeah, then there's no metadata in this NFT. So what it does is it takes it from the callback. But on the back transfer, there is metadata that I can query for here. And then I'm going to use the as a proof of source the metadata from the source from the home chain on Osmosis. So and so at the end it is just like I'm calling here the update NFT info for this token, updating the token URI, and adding updating also the on-chain metadata. That's for the receiving part. And if this fails on the receive callback, it's just like it will just roll it back. Yeah, so it will send egg fail to the source chain. On the acknowledge here, what I'm doing is just like same thing. I'm calling the update NFT info. Here it is so on the forward transfer, so the acknowledge happens on Osmosis. So I'm set, what I'm basically setting is like the token URI and with the S code PFP. If I do a back transfer from Stargaze to Osmosis, the acknowledge happens on Stargaze side. On Stargaze side, though, the NFT has been burned. So in this case, it will throw an error, but it is not a sub message. So it is just a fire and forget. So for simplicity. Yes, that's the main logic I wanted to show you guys. Any questions?
Thank you, Mr. T. Yeah, thank you for the presentation. Does anyone have any questions? Maybe I have a question. Do you know how many chains have deployed this contract already?
Yes, we have deployed on Stargaze, Terra, Juno, Osmosis, Aura. Now we are about to deploy it on Injective. Next, it's coming Migaloo and Neutron, and some other. So we have some other chains in the pipe. So the goal is, I believe, there will be a minimum of 20 chains by the end of this year, and generally, we want to deploy it on as many custom Watson chains as possible.
Cool, great.
Hey, hi, this is Tausif from Agoric. Tai, I will be happy to work with you for adding it in Agoric blockchain if you're not already working with somebody.
No, not yet. Really happy. Just DM me.
Okay.
And then via Telegram or whatsoever, Discord, Susanna has my contact details if in case you don't find me. And yeah, maybe anything else? I mean, otherwise, I can tell you a little bit more some background about CW ICS 721. So we have been working very closely together with also with the other team, Beyandi and IrisNet, who did the NFT transfer module, the ICS 721, the module version. And for us, it was absolutely important to have these incoming outgoing proxies. So it is there are rare cases where it is possible. For example, you can spam, a channel, for example. So with just a malicious collection contract, you just can really do a vector attack for that one. This way, we can really whitelist only trusted contracts, for example. So we are whitelisting not only channels, but also collections, checksums, so the code IDs basically, and on both sides for the channel, for example, if for the outgoing, so if you send an NFT, it needs to go to the outgoing proxy. So there's this, you have two options. You can optionally set an ICS an outgoing and incoming. So by default, it's none. But if you have set an outgoing proxy, it only accepts requests, transfers from the outgoing proxy. And that's how we can, and with smart contracts, we are much more flexible doing additional extra checks for security. So we can really say, hey, if you want to send an NFT, like that, you can only send it to this channel. If it's not whitelisted, we throw an error right away for the outgoing channel. But also on the other side, the incoming proxy does a double check, because you cannot trust any other chain. So it is possible that the other chain, so the source chain, either the chain or the contract or ICS or anything, it may get compromised. So the incoming channel, it is even possible to, here we are checking, okay, is this channel whitelisted? Yeah. If not, we phone act fail. And so that helps really us a lot, because we are really trying to make ICS as secure as possible. In addition, with the incoming and outgoing proxy, we also have a pauser. So a one-time pauser. This is the worst case scenario. If anything goes wrong, and we need to just exploit or whatsoever, relays get stuck, what we want to do is just like we want to halt ICS 721. So you can define a pauser, a wallet address, and then you can send this wallet, this pauser is able to send a pause, a signal to ICS to stop accepting any calls for a while until it gets unpaused again. So we have built on top additional utilities and security measures compared, for example, to the ICS module. There are some other things that you are aware of with ICS 20 with fragmentation. So there are nice side effects by whitelisting only channels. So ideally, you have only one channel between two chains. Yeah. But it is still possible that if you go from A to B to C to A and then to B again, then you would get a fragmentation of two collections on the same chain, even though it's from the same channel, but it because the class ID is different. So there are some thoughts of that we also here we can add additional utilities on the incoming, especially the outgoing proxy, that we may add an extra flag like single hop only, for example, so that would work like this: that if you want to transfer from A to B and from B to C, and you have this single hop only enabled, for example, then it throws an error. So which means that if you wanted to transfer to C, then you need to transfer first back from B to A, and then you can transfer really from A to C. So it only goes max one hop, transfer one NFT from the home chain, like a star, to B, C, D, E, F. So this way you can also avoid fragmentation, and also it would allow you don't need some extra setup like a packet middleware forwarding, something like that. So there are these kind of things we have in mind. But in our roadmap for ICS, the next thing is just like really on-chain metadata and royalties. So just like very creator specific utilities, so that creator have full control of their collection, no matter where they are going to transfer their NFTs.
Cool. Thank you. I'll DM you to work further on this.
Yes, just ping us.
All right, thanks a lot. Anybody else has any more questions or any other topics to discuss? All right, then thanks a lot for the presentation, Mr. T. Thank you for joining us today. And thank you everybody else for coming today as well. Yeah, see you next time.
Thank you.
Thank you. Bye-bye.
Thanks.